Hello, and good morning, good afternoon, or good evening, wherever you may be. I'm happy to be here to present here along with my friend and colleague, Tomas Prokop. My name is Chris Piasecki, and we're going to be giving you just a sneak peek into our full-day workshop called AI-Assisted Full-Stack Development on Power Platform. Personally myself, I have about 14 years of experience in software development and I've been working with low code in its earlier forms in Dynamic CRM since version 2011 and have stuck with it ever since and built my career on the Power Platform. But I do come from a career as well from full stack development. So working with traditional development technologies such as .NET and so on. And Thomas, do you want to give a little brief introduction to yourself?
Hi everyone. I'm very happy for this opportunity to collaborate with Chris on delivering this workshop because my focus has been for a very long time the matter of scaling the low-code practices to the enterprise level. And I've been building some very complex solutions with Power Platform, and that's the experience I want to share. And here with Chris, we have a lot of go-to procedures in common. So we decided to team up and show you how we can make this more efficient for all sorts of developers, even professional developers and people who don't have strong pro dev skills, but are now equipped with coding agents, which can do a lot in this new world of agentic engineering.
Absolutely. And just as Thomas mentioned about making developers more productive. And so that is a continuous cycle that we find never stops evolving, especially now as we're into this agentic first paradigm, where not only are you seeing agentic experiences being brought to end users, but also we're seeing a lot of the most efficiencies in actually the development lifecycle itself. So that is where our chat today and our full day workshop is really going to focus around, is making the development experience in low code more productive to keep up with the emerging advancements in this space. So as agents start to write more of the code itself gets cheap and disposable, but as a result, the foundation that it's built on top of, in the case of the Power Platform, that being Dataverse, setting the right foundations becomes very critical to make sure that the behavior and the business logic and everything stays accurate and reliable. So the system of record being Power Platform and Dataverse, holding your data model, your crucial business logic, security, your role-based access, auditing. Not just only now it's you as the developers and makers building, but now the coding agents transacting against it. So it's very important that we put in strong architectural practices and patterns to ensure that as we start to introduce agentic development experiences into that, it aligns with those same principles and patterns to ensure that the quality of the output of the solution is following it, but also as you start to introduce agents on the end user side, those same agentic or those same agents follow the same business logic that your users would have to follow as they're working through the user experience. So all the different experiences that agents introduce, you want to ensure that that's consistent across the stack.
So I would say that it's very tempting today to generate a lot of code that Power Platform provides out of box as a features, because now it's very easy to create net new code. But we're starting to get into a new problem. It's no longer about people cannot code, because they can now with coding agents. It's about who takes care of all the code estate that we generate and how we can make it run and be reliable for years as we need to run those systems. So we are facing quite some new challenges, but we believe that we can bring some of the well-established practices to make this easier, because we tend to see some similarities between how coding agents can be managed and how human developers have been managed so far.
Absolutely, Thomas, and that's just it. So, I mean, software development disciplines and practices haven't gone away. In fact, they've become more important because of the acceleration of this code. So, all those practices that we've been following for 20 years, it's how do we bring those into agentic development so that the agents that are developing on your behalf follow those same sets of practices. So that is why we have this workshop, is really to show you how we introduce that into not only just into Power Platform, but just in your general low-code best practices as we go forward.
Yeah, I think we have some interesting, perspectives now, whether people should go learn React and Python and start, going full pro code way, or whether it still makes sense to introduce some of the low code components in those solutions. So we're also having these discussions, and we're wondering about what's the direction in the current landscape. And I think it's pretty clear that there is no single direction or opinion that people are taking right now. But I think that as we experience the life with coding agent, we slowly start converging on some problems that we face, like the flood of pull requests and the inability to integrate the code as fast as we produce it, and how we can make sure that we can test it properly and validate it, because if we let AI write tests, can you really trust those tests? So there are all sorts of new questions, but I think we're all getting some sense of what this is going to be, and again, what kind of practices and processes we need to put in place.
And that's exactly, and a lot of those things that Thomas was describing is what we kind of refer to as the inner loop of development. So all of those challenging things, right? So how do we go ahead and build the software? How do we ensure that the software that we build passes the minimum criteria of safety checks? So whether the solution can build, is it secure, and does it pass minimum set of acceptance tests to ensure that when we deploy it into the user community, is it going to behave as we expected? Is it going to have issues or bugs? Is it going to have potentially security issues? So that inner loop is where our workshop is going to focus on. Of course, the other gates of the software development lifecycle, like the outer loop. How do we actually securely deploy and release the software out to users? And then, of course, wrapping security around that. How do we detect vulnerabilities and issues and further harden the solution to protect from the ever-evolving threat landscape out there? So again, of course, an important part of the overall life cycle, but the challenging bits where we're going to really gain efficiencies from is that inner loop phase, and that's where we're going to take you on that journey throughout this workshop. So in terms of what you're going to build throughout the day, we're going to actually run you through a real world scenario of building a full stack Power Platform solution and wrapping lifecycle management all around it. So what does that look like? We're going to build a Power Platform app using the newer modern code apps as the front end. We're going to wrap that around a data model, of course, that's going to have your Dataverse tables, the column definitions, all the business logic, which gets implemented through plugins, extending the user experience through PCF controls, code apps, and of course, how do we package those up into solutions that we can then distribute them and push them to downstream environments. We're going to use Git as a single source of truth, as a standard in software development. So we're following that practice of environments themselves should be disposable or transient. We should always be able to rebuild an environment or rehydrate a development environment from the source code repository. So we're going to ensure that we're enforcing best practices around using Git from the get-go. We're going to also wrap that around some continuous integration and continuous delivery pipelines using GitHub Actions. So as we talked about, how do we enforce those quality gates on every commit or pull request into the main branch? And how do we deploy securely without leaking secure credentials to bad actors? And then also, we're going to actually show you how we use coding agents to rapidly speed up this process while following the conventions, standards, and practices of our as a standard development practices that humans would follow. So we'll actually see how you can actually direct it, and we'll also ensure that we'll be able to provide all the sort of manual fallbacks and scripts at every step so that you can reproduce to a consistent state after every step in the process. So we'll build, as I mentioned, many demos that you've probably seen today using Code Apps or the new Vibe experience. Is the great part is that you're able to use a coding assistant to very quickly scaffold the user experience or the front end of it. But a lot of those demos sort of stop off there. I mean, that's sort of the easy part, right? Coding agents are very good at making very sleek, beautiful designs in just a matter of minutes. But actually making sure that that is maintainable, that's built on a good, solid foundation, is a lot of what these demos really don't cover. And so, in order to operate a real world solution, you really need the full stack to ensure that you're building a quality solution that's going to survive the test of time, right? And it's not going to be, a throwaway solution after the demo. So we're going to really show you not just going through a front end that's built in a code apps using, the standard React, TypeScript, and other common libraries that we use, but also building business logic through code first experience, such as C# plugins and custom APIs, running inside the core Dataverse platform, running inside a transactional system, ensuring that data stays consistent and business logic is enforced regardless of where you're running the app, whether it's through your front-end code app, whether it's through an agent-first chatbot or another agentic experience or other custom integration. You want to ensure that the same rules are enforced regardless of where the data is being interacted from. We'll also introduce ways to introduce background workers using custom connectors, Power Automate flows, so integrating that into the code apps, much like you're used to with your traditional Canvas and model-driven apps. And the way that we're going to be doing this is we're going to manage this through one Git monorepo. And the benefit of this is that it will give your coding agent the full context to all of your solution components and your code so that it can make the best informed decisions based on the instructions that you give them. And not only that, we're going to be building it in GitHub Codespaces using Copilot. And so a little bit about what that actually means is that normally when you're having to develop your Power Platform solutions, having to set all this up locally means installing a lot of tools. So you have things like Visual Studio Code, .NET Framework for developing C# plugins and backend processes, maybe running Node and TypeScript in order to build your front-end experiences. You have Git, of course, to manage your source control, and then various CLI tools like GitHub Copilot, Power Platform CLI, and so on, just to all get this going, getting up and going. And so in order to make this more frictionless, we'll be leveraging GitHub Codespaces, which will essentially provide this fully built local environment available inside of your browsers, inside of a GitHub Codespace. So you'll have everything that you need to start building and not have to do that on your local machine. So what does that actually look like? Well, so again, when we talk about Power Platform and when we think it's low code, well, when we start to getting to the extensions and code first experiences that requires full developer tool chains, that again, the Codespace is going to provide each of those parts, core components needed in order to do what you need to do. So VS Code is going to be the editor that we're working with, augmented through GitHub Copilot CLI to provide the AI coding assistance that will help you develop the code in a rapid format. Git, as I mentioned, will be the source control tool that we're using. So the Git client will be installed. It'll manage all your history, create checkpoints throughout the lab as you build them so that we can revert back if there's any issues along the way, especially with the agentic coding agents that sometimes are not going to necessarily follow the directions that you need. So being able to quickly go back and revert will be super important. We're going to be relying on, again, a number of different development platforms and frameworks. So using .NET and Node.js to help build and compile your code. And then the various CLIs to actually deploy and talk to the various services like Power Platform, Azure, and also using the .NET CLI as well to manage building of your solutions. And in order to make the coding agent more reliable and have the context that it needs to work within Power Platform, we'll be leveraging what are called skills and plugins in order to give the coding agent the knowledge that it needs to be actual to perform the operations and work with Power Platform components along the way. So with that, I'm going to hand it over to Thomas to give us a demo of what the actual Codespace setup looks like. Thomas, over to you.
Thank you, Chris. Let me share my screen. So traditionally, you're probably used to work in this user interface where you can create different components, you can publish their versions to your users, and you can use solutions and solution framework to segment the components you create and distribute them between various environments that you have in your tenant. We won't be covering this part of the experience too much during the workshop, but as Chris mentioned, we try to take a different approach, which is now more native to how we work with coding agents, and that's a code-first approach where we set up a Git repository where your agent will operate and will create those components and deploy them to your environment. It will sync the changes from it back to the original environment. And how we envision the lab to work is by splitting it into multiple checkpoints. So we will work throughout the different stages in the developer inner loop, and you will be using the coding agent, in this case GitHub Copilot, to drive through the steps, and it will help you select the right commands based on the skills that we will provide to it. And because we're working with GitHub here, we can use this super cool feature which is called GitHub Codespaces. And to give you a quick taste of how this works, so you can try it out before you attend our workshop, you can use a repository that we have prepared, and you can create a fork of it. This is like your own copy for making your own changes, which are separate from the central repository where we have all the samples. So if you create a fork, you can then operate on it with your coding agent and load it in your own virtual environment, which is called Codespace in this case. So if I hit a button called code here, I can see that I can create a code space, which pretty much starts a virtual machine on the GitHub side. This is completely managed for you. And you can then run VS Code and coding agents within it. And it is nicely integrated with the GitHub experience. So I've already created one code space, which runs on top of my forked repository. And if I jump into it, I will get, in my web browser, I'm still running in a web browser, I will get the Visual Studio Code experience where I have GitHub Copilot chat on the right side, which drives some specific steps that I asked it to perform. And I can see it performing terminal commands. So it asks me to review the pull requests, which are part of the lab that we will be executing, and I can see all the changes that it's been doing here with the full history, so I can see exactly what has changed. To give you a bit of idea how that will look like, I will open the GitHub repository that I have forked. And we will see a history of pull requests. Pull requests are a way how you can actually take a set of changes that you have created in collaboration, for example, with your coding agent, and prepare this change set for a review, which is either automatic or at the last stage, human code review. And that helps us developers to integrate the changes and properly review them. So you can already see that I have different checkpoints throughout the lab laid out here, where we create the individual steps we need to take to set up our repository, configure the connection to our environments, set up the pipelines and GitHub Actions, and then provision the components of our solutions, like data model. So when we're creating entities, I can see all the forms and views laid out here as code. I don't need to read it. I have my coding agent, so I can ask all the things about it. So it kind of resembles the ease of use when I'm in the user interface and make.powerapps.com, but I have the code here, so my coding agent is more productive and efficient. But what's a really important part about this is to have an ability to validate what the coding agent does, because it is far too easy to make some direct changes by the coding agent to the code of your Power Platform solution. But if you don't have a way how you can validate that it's actually correct and that there are no invalid mutations to the code, you can discover that far too late after you deploy the application. So we will be trying to show you how to set some guardrails to prevent some common problems. Also, as part of our lab, we will be covering how to build both metadata-driven, model-driven apps, which are kind of usual for us in Power Platform, but we will also get a taste of what it takes to include Power Apps Code app in your solution. So in this case, we will be building a warehouse management system where we have two interfaces. We can see the database and the forms through the perspective of let's say a back office worker. So we have traditional forms and views and sitemaps and model-driven Power Apps, but we can also add an experience which is driven fully by custom UI developed by the coding agent using the very same backend, in this case Dataverse, with all the tables and plugins. Maybe, Chris, I would hand it over to you a little bit to talk about what kind of value we get from bringing Dataverse into the play and how specifically it works in our sample that we will be working on.
Yeah, absolutely. Thanks, Thomas. As we talked about earlier, it's very easy to get a demo and build a front end and using a code app. But again, the important pieces that often get missed is the business logic. And oftentimes you'll see that business logic implemented directly in the front end, which of course introduces a number of challenges. Is that if you start to introduce other experiences where that data can be interacted with, you have the potential for business logic to be bypassed because you've implemented that for example, in your code app. But if your agent or your chat interacting with an agent through a chat experience, well, then those same business rules can get bypassed. So it's critically important to introduce that sort of essentially close to the data as possible. And that's where the advantage of Dataverse provides. And so we're going to build up your data model, and we want to ensure that we introduce that business logic and enforce it on the server side rather than on the client side, so being at the app layer. So that way you get the same behavior regardless of where that's introduced. So take a common scenario in our warehouse picking scenario. So a lot of times you may need to pick in order, and you have a warehouse that's tracking the amount of stock that you have per particular item. And so oftentimes you may have various orders coming in from many different purchasers or whatever that may be. And so as they're making orders and they're picking stock, that stock will, decrement, become less, become lowered after every time, say, an order is picked. And so you may have this scenario where you may have concurrent orders being picked at the same time, and you may have not enough stock at the time that both of these orders come in. And so how do we ensure that the business logic or the picking operation ensures that the correct stock is reflected at the time that the order is being picked, and that you don't over allocate or over provision the amount of stock that you have based on what's available. And so if we were doing this in the client-side validation, well, that can be a problem, because if it's calculating that on one user's machine or in their browser, it may not be reflective truly what's available on the server because of what another person is doing. So Thomas, did you want to show us a little bit what the code, how we may get across or get around this challenge?
Yes. So as Chris mentioned, we can head different directions. We can implement some validations and input hints on the client side. That's usually when you create a Canvas app and you set up some filters, or you create a model-driven app and you create some scripts that run on your form. So I have an example here where I have some scripts and buttons, and they do some logic, but once you start using things like Dataverse MCP, it is extremely easy to get around all of that. So if you want to add some, guardrails for your business process and really enforceable logic, you will step into implementing Dataverse plugins. So we also have an example how that could be done. So we have a very simple sample here of handling movements on the warehouse in the inventory, which validate and count the quantity. So we can really make sure that no matter whether it's user through the app or a headless agent or a Power Automate automation who executes the transaction, it gets applied consistently and validated consistently. So this is also the part we will try to include, and that's why this workshop is about the full stack approach. So we're not just focusing on generating the front end part, but we're also trying to show you how to combine all of this into a holistic repository end-to-end solution, which you can build, validate, deploy, and test as a single unit of deployment.
Yeah, thanks for that, Thomas. And I guess maybe just to kind of wrap it off a little bit on agentic architecture and how that will be playing a part in our workshop. So again, we're going to be leveraging GitHub Copilots, but you may also bring your own. We encourage you to bring whatever agentic development tool that you have available, whether that's Claude Code or Gemini or whatever tool or coding agent you are familiar with and have available to you. But again, all of these agentic architectures will effectively be the same in that they're always backed by a large language model. So if that's using Claude, GPT, Gemini, or any other of the available models out there, they take an input and produces an output. So it's just doing inference. There's no sort of tools, contexts, or memory between requests that are aiding that. You need something that kind of feeds that model, the context that's needed to produce the output. So that's where the coding harness comes into play. So the app that basically calls out to the model and adds additional capabilities. So this would be Copilot CLI, Claude Code, Cursor. All of those harnesses are work with the large language models to gather the context, call the model, execute tools, so talking to external services, do validation and verification, and continuously do that in this loop. And then you have what's called a context window. So again, this is everything the model can see during the inference call. And this is what becomes kind of expensive to manage. And if it becomes too large, well, then the quality of the output becomes less predictable because there's more instructions, more tool outputs, and more information that the large language model needs to work through, and it may miss certain things. So managing that is also what the coding agent is responsible for, along with the user ensuring and managing that context window as well to ensure that you get reliable output. So as part of the workshop, we're going to basically walk you through in more detail what this looks like, all the different tooling and capabilities of that coding agent has for you to take advantage of and ensure that you are developing a quality Power Platform solution. So we'll talk about plugins, what are hooks, MCP, skills, instructions, all of that and more we'll talk about in our full day workshop coming up in October. So with that, I want to thank you for tuning into our 30-minute sneak peek, and we look forward to seeing you in Las Vegas in October.
Hey guys, thank you so much. Thank you, Tomas. Thank you so much, Chris. Thank you for your preview, and thank you for everyone else who joined us today. We hope the session gave you an insight into what you'll experience during the full day workshop at PPCC26. If you're interested in any of the other workshop previews, check out the link below. I think, Thierry, if you could pop that up there, we'll have that go slowly for a little bit. If you're interested, check that link out. It'll be a link to the other previews that'll be offered over the next 2 weeks. If you haven't registered yet, there's still time to join us in Las Vegas. When you register, simply use one of the speaker discount codes shown on the screen to save $150 off your conference registration. So join us in Las Vegas to connect with thousands and thousands of Microsoft technology professionals from around the world. You'll learn directly from Microsoft's engineering and product teams, as well as some of the most respected experts from the global Microsoft technology community. Thanks again for joining us. We look forward to seeing you in Las Vegas. Have a great day and see you at PPCC26.